Sure.
Hello, say I have a question. Is Mthembu Mxolisi also a tutor? Mthembu Mxolisi, is he also a tutor because his mic is on and we are listening to music?
So.
Okay, no problem, thanks. Okay, no problem.
Please. See. Hey.
Yes.
When's that?
Yeah. Can you please mute your mic? Please mute your mic. We can hear your conversation.
Yeah.
Someone is on the call.
Iceda ukuqala man.
Uzosivisa ama-secrets akho wena.
Yeah. Ikhona la ku Outlook.
Mxolisi.
Sorry.
Yes, your mic. Okay. All right, that happens. Anyway, it's no big deal. But anyway, our first question, let's see where that question is. Should be number 11. Okay, I can see that. That's number 11 on Funda. I've shared with you a snippet of these questions. So if you were able to work them out prior, that's even better. So the first part of this question gives us a notation. So it's just an instruction on the notation. And it says the vector A, which is represented by A and theta in cornered brackets, will be a shortened notation for the x component, which is magnitude of vector A cos theta, plus the y component, which is the magnitude of A sine theta. So if you remember your vectors A and B, let me just also make sure I've got my working screen showing there so that we can, as I explain, you can be able to see what's happening. So with that notation, I'm sure you already have done vectors by now. And if we have a vector that is drawn on a Cartesian, and that vector is vector A, then the x component of that vector A will be A cos theta, the y component will be A sine theta. And theta is the angle that the x-axis and the vector subtend. Okay, perfect. So what we're talking about here is a vector A. That's our y-axis. That will be our x-axis, x and y. Then if we have a vector, and we call this vector A, and this angle is theta, then we know that this component in the x is A cos theta. So x, or we can use the notation I. So that can be I, which is the unit vector in the x direction, or this can be represented by unit vector j in the y direction. So this is A cos theta in the I direction. So I gives us the unit vector, meaning its magnitude is 1. It just shows that that's along the x. Whereas the component that's in upwards or in the vertical will be A sine theta, and the direction is the j with a unit vector like that. So when we add the two, if we would add the two, A is basically a sum of the x component, which we can say, let me call it B, plus the y component, which is vector C. So usually you say A equals to B plus C when you're dealing with the vectors. And this B, in terms of the magnitude, what is given there, the magnitude of B is still A, but it has got a cos theta component and it is in the direction of the x. So when we write our A, vector A is therefore equal to the magnitude, A cos theta, and the direction there is given as that, plus the B, which is B plus C, so the C component is still A, sine theta, which is the magnitude of the vector in that direction, but which direction? J. So that's just a thing of notation that we are being presented here for our vectors. It's no rocket science. Okay, so okay. So with that, let's deal with the question at hand. If A is, if you can admit, guys on Teams, if you can admit anyone, please do that. If you can see anyone that's in the lobby, please do admit them. That won't be a problem. That's if you see that pop up. So did we follow that so far? That's basically the issue with the vectors, what we have just been showing there. Can I kindly ask one of you to go over to the YouTube channel and check if it's showing properly, maybe via your phone. Can you check for me if the video is showing there and everything is fine? Because I'm seeing something weird here. Please, can someone do me that favor? Just go to the link for the YouTube channel, the Ebo Physics YouTube channel, and just let me know if everything is fine there.
Yes, it's showing fine.
A
I
nice
just
one.
entered.
Thank you for that one. Thank you for that confirmation. Okay, cool.
Yes,
Okay, so back to our question. Our question now requires us to find the magnitude of the vector C, which is an operation of based on vector A and vector B. So C is equal to 2A minus B. So how do we work that one out? Anyone who would want to just describe to us what we should do? I'll do the writing. So unless if you have the answer already, you can share it with us and let us know what you did. Anyone? So we are given vector A. We have, we're told vector A is equal to so vector A is equal to 12I minus 16J. That's vector A. Whereas vector B is equal to negative 24I plus 10J. So those are the I and J components of the two vectors. And we need to find C, which is 2A minus B. How do we get that? How do we find the magnitude? Remember, I want the magnitude of C. So after finding C, we need to find also magnitude of vector C, like that. So what's the process? What's the process? It's fine, even if it's simple. Share with us how simple that is, please. What do you think? Come on, guys. Come on, guys. You can do this. Anyone? Don't be shy. There's no wrong answer. There's no wrong answer. But the reason we are here is because we want to learn. So whatever you share, yes, Koketso.
Yeah, I was thinking that first of all is to find like simultaneous. I
Okay.
don't think it's gonna apply. No, actually, I just realized that I'm wrong.
Okay, you have corrected yourself. That's good. So in what way are you wrong, and what's the correct way to continue?
Okay. Yeah, I was thinking about like equating the two, to equate A and B, but actually that's wrong.
Right. So we need to do an operation which will consider twice the magnitude of A, or twice the value of vector A minus the value of vector B, right? So it should be twice vector A minus vector B. And when we make this operation, we operate on the I components alone and the J components alone. So anything in the X will add to anything else in the X. Then components that are in the Y, or terms that are in the Y, or Y and J are the same direction, will add to all other components that are in the Y. So what is 2A? So 2A will be 2 times. So I'll put my vector this way, so that anything that's in the X will be at the top. Anything that's in the Y will be at the bottom. So I can represent my vector in terms of I and J like this. You know matrices. Then this is minus B, where B is negative 24 and 10. So this is representing, the top part is representing the X, the bottom, the Y, or the I and the J. So what does that mean? That would mean, therefore, I can do my arithmetic. 2 times 12 there, 24. 2 times minus 16, negative 32. And this is subtracting negative 24 and 10. And if we are to work that one further, what would we have? 24 minus 24 should give us 48 positive, right? Because this becomes a plus. So we have 48 there. Negative 32 and negative 10 makes negative 42. So in other words, this is 48I minus 42J, if you want. That will be your vector C. This is vector C. But what does the question require us to find? What should we find according to the question? What do we want? Thando lwethu.
So I want to ask you, why didn't you substitute vector A and B to get vector C, like directly the normal way, not using matrices?
Oh, I could do that. I could do that. I just figured matrices are more presentable for my case, so it would still be the same thing. So maybe let's go that route then. Let's see. So we've got 2A, right?
Yes.
So vector C is equal to 2A minus B. We want to which is 2 times vector A is actually 12I minus 16J, right? 12I minus 16J. Then we subtract vector B, which is 20 minus 24I plus 10J, like that. Then we expand, we get 24I minus 32J, then minus 24, which is plus 24I, then minus 10J. Then we take like terms. If we take like terms, 24I plus 24I, 48I. Minus 32J minus 10J minus 42J. So these two are the same. Those two are the same. So I just chose, instead of expanding it like that, I just chose to take my I and J in that notation. So whichever way you are comfortable with is still fine. It will get ultimately to the same answer. Are you answered?
Yes, I'm answered. I just noticed that I added the I and J instead of I and I. I think those
Oh,
two are
yes. So be careful with that. Good. So you have to be careful there. Make sure the terms are the same. You can only add terms that are in the same direction. So the I, S to the I, the J to the J. Don't confuse those ones. Okay. I think that's a good observation there, which everyone has to take note of to avoid making errors. Thank you for that, Chandoletu. So far, this is our vector C. So because we have vector C, our question, back to the question, what does the question require us to find? What does the question require us to find?
Question.
I didn't get that. I missed something there.
It requires us to find the magnitude of C.
Yes, it requires
okay,
us, very good, to find the magnitude of C. So how do we find magnitude of C now that we have C?
We perform the Pythagoras theorem.
Very good. So can we do that? Can we do that and see what answer we get? What have we got so far?
I got 6 root 113.
Okay. Come again. You said you got
6 root 113.
6 root 113.
Yes.
Let's see, 6
Square
root like this.
6 multiplied by the square roots of 113. Yes.
Okay, which is 63.8. Okay, you
Yes.
gave us that in set form. That's fine. Let's see. Let's check. We've got answers given there. Which one will be the correct answer? Or the most appropriate?
64.
64, yes. 64 is given to two significant figures. So that's 64. So 6 root 113 is fine. So that's 64. I hope we can all follow that, guys. I hope you can all see that. Our magnitude for vector C will be 64. So that's very good. That's fine. That's fine. So depending on, in this case, you are given your components to two significant figures. So our answer is also to two significant figures. So that's 64. That's fine. Question 12, if we can proceed, let's attempt this one. Let's attempt this one. The notation again is presented there. A theta in square brackets represents A cos theta I plus a sine theta in the j direction. So you are given A to be 15 and 80 degrees for theta, and B to be 12i minus 16j. What is the magnitude of A minus B? What is the magnitude of A minus B? So anyone who can lead us and tell us what we should do? Or if you want, you can work it out from your side. Tell us what you get as your answer. Any volunteer? Yes, I can see Pilencha.
The first thing that I think we can do is to identify the magnitude of vector A, which is 15, and the magnitude of vector A 15 is 280 degrees. That means that's the angle that we get. That means vector A will have component X and component Y.
And what are those?
So
Yes, continue.
AX A component of x is going to be 15 cos 80, and
Okay, good.
the y component is going to be 15 sin 80.
Wonderful. 15 cos 80 in the x. Is it plus or minus?
It's plus.
Yeah, someone is clapping hands. They're impressed. Well done. That's very correct. So 15 sine 80 in the j, like that. So we now have our vector A. Thank you for that. That's very, very correct. On
Yes.
point. And so what do we do, because the question doesn't end there, what do we do from here? Anyone wants to continue, or if you would like, you have the platform. Would appreciate if you take it through to the end. So we have A expressed in already in terms of the I and J components, and we have B also given as B is equal to 12I minus 16J, like that. And the question requires us to find the magnitude of A minus B. So where do we go from here? Where do we go from here? What do you think, guys? We have A and B, and we're doing the same thing. We want A minus B. So what would be A, vector A minus vector B? We can express 15 cos 80 as a number, if that's what is confusing you. Where is my calculator? Just go there, 15 cos 80. I hope that's in degrees, 2.605. So we've got for A, 2.605 I, then 15 sine 80. Sine 80 is giving me 14.77. So that's plus 14.77 J. Then minus B, so that's A. This is A. And we need to subtract B, which is minus 12I. What follows? What do I do there? Is it minus 16J? So minus 12I minus 16J, like this. And if we remove the bracket, if we would remove the bracket, take note this negative that's already here, and the negative that's in the equation, in the expression that we are dealing with. So this is the negative for the expression, and if we remove brackets, then this becomes minus minus, so it becomes plus. So that's also important to take note there. So this is actually the minus B. This expression there is the minus B. This is A. So minus B is basically negating that whole expression and bringing them together. So now what did we say we do after this? I'm now going to keep quiet. I think we're at the point where you now have to show that you picked something from the previous question. Go on.
The i's together. I think we add the i's together, which is 2,605 minus 12i.
Yeah.
Plus 14,77. If I click 14,77 plus 16, when I get the answer, it will be the answer I got when I added. Okay, plus in brackets 14,77 plus 16.
Okay.
Close up. Okay. And when I click that on the calculator,
yeah,
it will be 2,605 minus 12i. We get negative 9, 14.39
All right.
and 14.77 plus 16, we get 80.77J.
Okay. Wonderful.
And after that,
yes,
we can do the Pythagoras.
for the magnitude. So now after that, you have to do the magnitude of A minus B, which is the square root
Yeah.
of negative 9.39 squared plus
Plus
30.77 squared. All right, wonderful. Well done, Bali. Thank you very much. So what is that magnitude? What is that magnitude? Let me also go to my calculator just to cross-check the square root of
32.
Oh, someone got it already. That's 32 point
2.
point
32.2.
point 2. All right. And do we have units? Do we have units? No units were given, so it's just a number, right?
Oh, yes.
Just a number there. Do we have 32.2 there to two significant figures? That's 32. So our answer should be A, B, C, D, E. Which one? A.
32A.
That's A. So we'll choose A there. Okay, that's perfect. That's perfect. So far, so good. Similar question, maybe a bit different.
Before
Yeah.
before you move to question 13, can I ask now? Is there a question whereby we are just given the polar coordinate and we are required to find a vector of let's say we are given polar coordinate of two vectors and they want the summation of those polar coordinates. Is there a way
Yes.
whereby we can directly find the coordinate without finding the component, the vector?
I think it's always wise to go the component way first. I don't think there's any other way because you have to solve the coordinates into components. You have to take those polar coordinates and take the components so that you deal with the components in your operations. I don't think there's any other shorter method or any other method that you could tend to.
Okay, answered.
Okay, cool. Thank you. That's how do I pronounce your name? Mateo.
Mateo. Yes,
Mateo.
sir.
Oh, wonderful. Okay, cool. Thank you for that question. So yeah, just use at times you don't want to lose marks unnecessarily. At times you also need your method marks because the working is also very important. So just take things step by step. You get your components, operate the components of the same direction together, the I alone, the J alone, and get to your final answer. So it's also important, these questions, when they say magnitude or present it as a vector. If it says just find the sum of vector A plus B, then make sure you give it as a vector, meaning there should be magnitude and there should be direction. But if it's find the magnitude, then you can only give the magnitude. So those are the things that you should look out for in the questions that you come across. Okay, so we have a different question there. If there are no other questions from you guys, let's attempt the one on the screen right now. So the two, like you were saying, in this case, the two vectors are both in polar coordinates. And the question requires you to find the magnitude of the sum. Find the magnitude of the sum of these two vectors. Find the magnitude of the sum of these two vectors. Can we do that for this one? I think I would wait to see your answers. Can you work it from where you are and tell me what you get? Tell me what you get. How far are we? Anyone done?
I would like to try. I'm not sure if I got the
Quickly
angles
try.
correct, but I'd like to
Okay.
try.
Let's see how far you
So
went.
I think that we need to express vector A. We need to say 10 sine
10
10
sine.
sine 30 for the j components. We'll say 10 sine 30 is equal to 5 j for the j component.
Okay, also for the j component, so the first one is the x component, so plus 10 sine 30, which is 5, right?
Which is 5, yes.
For the j component, so this is 5j. And for the x component?
For the x component is x, 66.
8,66.
I mean, it's 8,66. I'm sorry, 8,66.
Yeah, okay, 8,66i. Okay. So this is our vector A.
Vector B, yes, this is vector A. And now we go to vector B.
Right.
We also express vector B like we did in vector A, which is 25 sine 130. Is equal to 19,15.
19,15j. Okay.
Yeah, 19,15. And for I, it is negative 16,07.
16,07 I. Okay. That's for B.
And now, since we have both vectors, we say A plus vector B. Vector A plus vector B is equal to 8,66i.
Right.
In brackets 8,66i plus
Continue.
5 plus 19,15j.
All right, plus
The j
5 plus 19,15j.
Yes, 5 plus 19.
Is the first part all right? 8,66 minus 16,07i, right?
Yes.
Okay, good. And what do we get?
When I click that on the calculator, 8,66 minus 16,007. It gives us negative 7,41.
Negative 7.41, like this, I.
Negative 7,41 I, and 5 plus 19,15 is equal to 24,15 j.
Okay. That's
and
our
from
A
here we
minus
can
B.
apply Pythagoras theorem.
From here we apply Pythagoras theorem. Okay, so the magnitude of A minus B from Pythagoras theorem will be the square root of negative 7.41 7.41 squared plus the square root plus the square of 24.15. And that should give us what? What does that give us? What's that?
25,26.
25.26. Okay. So this time I think we have meters here, right?
Let me see. I can't see the question correct.
You can see the question clearly. Let's see.
Okay, let me go back to the question.
Yeah, it's meters.
Yeah, it's meters.
It's meters, yeah. They were given units for distance and degrees for the angle. That's good. So that's meters. So our distance should be our displacement otherwise, or the magnitude. In this case, it's distance if it's magnitude anyway. The distance there is a magnitude of 25.26. And so this one, that would mean D. That would mean D. That's for A plus D. It remains there. Okay. I think that's quite straightforward. You guys are nailing it. You guys are nailing it. The next one will be this. Is it a simple one? Okay, I like this question actually. On occasion, the notation vector A given by magnitude of A and theta will be shortened for that, as we have said already. The diagram below, exhibit 3.4. Yes, Koketso?
Yeah, so on previous question, like I've got the very same answer, but the thing is, I used it on my own way, say like
You got the same
instead
answer.
of yeah, instead of doing that, like the question was like, yeah, 130 degrees, but I used 50 instead.
You used 50 instead.
Yes.
Motivation for that? Why would you use 50?
Okay, angle on a straight line is equals to 180. So I've got a negative displacement, negative 25 cos 50.
Negative 25 cos 50.
Okay, let me talk about my horizontal displacement. I've got positive 10 cos 30 and then minus 25 cos 50. 50 I got it from angle on a straight line, which is 180 minus 130.
180
So
minus 130.
Yes,
I see. Okay, so the angle on the straight line, this will be
is 180.
This will be 150. So this theta there becomes, is it 130? 130 actually.
130.
So this theta there becomes 50.
So it creates
Then you have
50, yeah.
Your
A negative
25.
displacement.
Vector there is 25. Then this becomes minus 25 cos
Yes.
50.
Cos 50.
In that direction. Okay.
Yes, sir.
And how
Yeah.
does, and for your J component of that same vector, what do you do with the 50? You say sine 50, 25 sine 50.
Yeah.
25 sine 50.
25 minus 25. Yeah, 25 sine 50, sir.
Okay.
Yeah.
We'll put your method to test in the question that follows, the question that's at the end. It's actually quite cool. I think you would need, if you are gonna do this, then there's some consistency that you would need to apply through to the end, because it's working, it's fine. I commend you for that. But let's see if that method also works when we look at the question at the end. I think I'll bring you back on the spotlight when we look at that question, because this one was requiring us to find magnitude, and it's fine because you have even chosen your directions, correctly to say, because the other one is in the opposite direction, is still minus 25 cos 50. The good thing is when you remember your quadrants, right? With your quadrants, you've got the first quadrant with all your trigs being positive. Then the second quadrant, it's only the sign that's positive, and the cos becomes negative. Right. Hence you have a negative there. But yeah, once you have an understanding of what's happening there, I think you can always find a way to maneuver. But consistency is also the key. Thank you for that. Well done. Well done.
Thank you.
Okay, I'm not gonna say anything about this question. I would want you to try and work it out in the shortest possible time. So the question says the diagram below shows the path taken by a sailboat tacking sideways because it cannot sail directly into the wind. So remember, if we have a wind in a certain direction, you would need to maneuver against the wind so that you actually land into the direction in which you want. Otherwise, if you just go straight thinking you're going to point C, you end up deviated by the component of the wind that's going against you, and you miss point C. So according to this diagram, I don't know if, let me see. Okay. Is my mouse, is my cursor visible on the screen? If I hover on top of the diagram, do you see the cursor?
No.
You don't see the cursor, unfortunately. Okay, but anyway, the diagram is something like this. That's the diagram, and we're moving from point O, from the origin. Then there's point B there, and there's point C at the first landing point. So if ideally this is the boat, right? If that would be the boat, and it requires to go to point C, it would need to use or to move in the direction towards B, so that the component of the wind that's downward, it just shifts it in direction, so that by the time it traverses all that distance, it is actually at point C, because it's now, this component is what the wind is adding. So this is the wind component. It adds that component to the direction in which the boat is moving. And at the end, that's how it can land. If it goes directly to C, because of the component of the wind, you will find at the end of the day, it's landing there at D. So it misses the point. So it has to go against the wind. It has to sail into the wind. Okay. So besides, anyway, that's contextually, I think it matters to understand that at least in a way, so that at times you can work the question in an easy way. But then, because of what we are given here, we have got a displacement in the north of 1,000 meters and a displacement in the direction B of 2,000 meters. And we are not told of what displacement that is from B to C. But then the boat continues again with the displacements, and we have a displacement to D, and we get to E at the end, which is 6,298 meters away from O. Now the question says, the total displacement of this, refer to the exhibit 3.4, which is this diagram that we've seen. The total displacement of the sailboat, the vector sum of its displacement OB, BC, CD, and DE is what? So after moving OB, BC, CD, and DE, what is the total displacement of the sailboat? Who can give us an answer there, a quick answer?
4,000.
What is that? Come again, I didn't get that. I would like to hear that answer.
It's 8,000.
8,000. How did you get to 8,000? How did you get that?
I think it's 8,000 because I added the distance. between zero, I mean between O and B and C, C, D, D, E, and then it gave me 8,000.
So you're adding 2,000 plus 2,000 plus 2,000 plus 2,000.
Yes,
Yes.
sir.
Okay. We have from O, we have A. Leshawanolo, you wanted to say something? I saw your hand. I was not ignoring you. I was just waiting to finish with what was happening here. A, B. Okay, so that's B. That's C. That's D. And that's E. And this is the easterly direction. Upwards is the north, and that height is 1,000 meters. This one is 2,000, and by making it okay, so if that is 1,000, you are assuming that you're assuming that B to C. Why I say B to C is 2,000 and C to D is 2,000? Is that not an assumption? If you say 1732, let me also check. Probably our assumption could be right, but yeah, we have some interesting stuff to discuss. Clear that 1732 multiplied by 4, 6, 9 to 8. Okay, so these intervals are the same. So we have these intervals. This is the center, that's another one, that interval there, that interval there. And if they're all coming to the same height, okay, 2,000, 2,000, 2,000, 2,000. All right. What the Leshaw, no, you wanted to say something. I'm back to you. Are you holding on to your idea? You don't want to share your idea with us. So remember, guys, what is the question? What does the question require? It's saying find the displacement, right? What is displacement? Back to definitions. Okay, Tando. People are getting bright ideas and running away. Okay, let's show Nola again. Come.
The displacement is the distance between 2 points.
Distance between 2 points.
That's the displacement.
So you are agreeing with the 8,000?
No, I don't agree with 8,000.
Okay, all right, I am getting it. So I would refine your definition. It is the shortest distance. Displacement is the shortest distance between 2 points. So that makes displacement have a direction because it's along a straight line. So from the definition, Tandoletu, say something.
No, so I wanted to say it's not 8,000.
Oh, you're also saying it's not 8,000. So I would agree with you. It's not 8,000. 8,000 will be the distance. Yeah.
Yes.
Oh, I think it's 4,000.
4,000. Why 4,000 now?
Because okay, you see, as the displacement is defined, I'm not sure now. I'm just taking
It's
the
fine.
shot.
It's fine.
As the displacement is being defined, it's a short distance of like a particle moving from one point to another point. So since like the distance is 8,000, the total distance is 8,000. I think the displacement is 4,000.
On behalf of it.
Yes.
Why it's supposed to be? It can't be half.
That's getting interesting. Yes, yes.
Okay, let me say the height of this is 1,000 meters.
Yes.
And then from zero in a horizontal direction, it is 1,732. Each
marking
each
passing
movement,
each marked point, yeah.
Yes, sir. So I can divide those triangles into 4 right angle triangles, so that I can use theorem of Pythagoras, I guess. in those.
Okay.
Because
Tanduletu?
there is,
Matteo, you're still saying something.
yeah, I guess if the height and the distance per, what's that point on the
Again,
horizontal.
Okay, so we're given 1,000. Look at my diagram here. We're given 1,000 there. And ideally, that would be 1,000 as well. But we're told this is 1732. And this is 6298. Which is 1732 times 2 times 3 and times 4. Okay. In Tanduletu? Are you going to say something? Okay. So take note, guys. This is basically a conceptual definition kind question. Yes, Tanduletu, you can say something.
Oh, sorry, sir, I didn't unmute the mic. I was saying if we divide the 6,298, it should have gave, divided by 4, it should have gave us the 1732, so that if we add them, we find the total displacement for the x-axis. So hence I'm saying it's not 800 because those are not right angles, triangles.
So what is our displacement? You are very right. So finish up your statement. Yes, it's not 8,000. I think even everyone now agrees it can't be 8,000 because 8,000 we have agreed that it's a distance. It's the total path traversed, total length of the path traversed, which is 2,000 plus 2,000 plus 2,000 plus 2,000. That's 8,000. But yes, Mbali?
Can you please define displacement again?
Displacement is the shortest distance between 2 points. Shortest distance between 2 points.
Okay, what
Or
if
its
we
distance
say
is distance in a specific direction, because it makes displacement a vector. Our distance is the distance from O to E in a specific direction, which is east. So the distance in the easterly direction to point E is what?
6,268.
Just that. So you didn't need to calculate anything. No Pythagoras, no vectors there, no nothing. You just look at that and say, okay, my definition, displacement, shortest distance between 2 points. O to E, 6298. You go to the answer. How is that? Do we agree?
Yes, we agree.
Yes, we agree. We should agree. We have no choice. We have to agree. The shortest distance between O and E will be the straight line joining O and E. And that straight line, no need to calculate. It's written there, 6298 meters. So what this is emphasizing is our understanding of these quantities. When we talk of displacement, we're looking at the distance in a particular direction. So it doesn't change directions. It doesn't go northeast, then southeast, then northeast, then southeast. We don't change directions. We're not looking at displacement. We focus on one direction, which is east. Then we see, okay, by the time we get to B, our displacement from O in the east direction is 1732. When we get to C, our displacement in the east direction is 1732 times 2. Okay, yes, Sizole agrees. Thank you for that. So when we get to E, our total displacement is 6298. So it's because it's a distance in that particular direction. Even if you would go in circles and decide to go first there and there and there and come back to this point, right? What would be the displacement in that case? If you would go, let's say this whole path here is 15,000 meters. What will be the displacement by the time we get to the same point O? What is the displacement?
Is it not 0?
Just like that, it's 0. You have gone nowhere. Yeah, for
It
just
is the distance between 0 and that specific point.
yes. So in this case, it's just the diagram is ugly, but we're saying we're coming back to this specific point O. So if we come back to that specific point O, our displacement is basically 0 considered in the eastern direction. But then remember, you have to give direction at the end of the day. That's why displacement has to look at in which direction are you pointing. If it were to land somewhere else, let's see what I can, if I can. Okay, so if we were to land here, what is the displacement in the x direction? If we land at, let's call this point P. If we land at P, what is the displacement? If we would go through that path, yes, who's saying that?
Sizol.
Okay, yes,
I think since you said that the displacement is the shortest distance that like an object travels, I think the displacement now is going to be P in the north direction.
Okay, very good. So if for this way half of 1000, then this will be 500 in the north. What about in the east? What is the displacement of point P in the east?
It's also it's 0.
It's also 0. Good. Just like that. So those are the concepts that you need to take note of and be aware of. There was someone with a hand up. I think I missed them. What was that? Snenjongo, you wanted to say something? Or probably I answered. And Bali, your hand is up. Is there something you wish to say?
Oh, no.
Okay, that was a hanging hand. That's fine. So we're back to the question similar to the previous. So this one is 6298 East. We'll just choose A. So 8000 is there to distract you. This is a distractor. Don't fall for this trap. So C is out. 2000 is not correct because it doesn't get as far as point E. 1732 East ends midway. 8000 Southeast is also wrong. So our best answer is, that's our best shot, 6298 East. This is a question similar to the previous one, which, who was that, by the way? Was it? Was it you, Matteo, who gave us an alternative method to work with those?
It was me.
Oh, that's okay, it's all right. Yeah, the one who worked that one out with the 50 degrees for the angle. Okay, so this question is basically a follow-up of the same question where in the previous, if you check here, we were asked to just find the magnitude. Question 18. It was saying find the magnitude with a 1030 and a 25 130 vector. So this is also the same 1030 and 25 130 kind of vector. And what we need to do is find the direction of the sum of these two vectors. Direction of the sum of these two vectors. So if you go back to where you worked the previous one, did I even work this question? I think you guys worked it for us. So yeah, the ones who worked that question, and I just drew this based on what Koketsa has been saying in terms of the direction. But now we need to find the direction of the sum of these two vectors when they add, meaning when their x and y components are added, which is a and d, a plus d. So what is that direction? What is that direction? What is that direction? Okay. So this you have already done, so it's not gonna be a problem if I do it for you the same way you might have done it. So we said our components for A plus D. So this is vector A, this is vector D. And our A plus D is equal to 10 cos 30 I plus 10 sine 30 J plus 25 cos 130 I plus 25 sine 130 J. And combining this, this was 5. I think I remember someone gave us these values. Yes. No. Yes, the 5 there, 10 cos 30, 10 sine 30, 25. So we have these values, 8.66 and 5, so that's cool. So 8.66 I plus 5 J. So at least you guys gave us some good values here, minus 16.07 I, minus 16.07 I, plus, what's the last one? 19.15 J. 0.15 J. And when we combined, I think we got something interesting, minus 7.4 I. So this is minus 7.4, 1 I. Then plus 24.15, plus 24.15 J. So this is for the sum. This is for the sum of A and D, whose magnitude we got earlier to be this. But then magnitude of A plus D, if you think of it, would be something like, this is your A, that's your D. You would simply do a parallel vector to A and a parallel vector to D. And you get a resultant vector. Can't I get another color? Yeah, blue. Nice. So you get a vector to that point. Okay, good. Which is vector A plus D. That's basically how you do with the drawing. You draw a parallelogram of vectors there, and you find the vector A plus D with its direction. But now the question only requires us to find the direction. It requires us to find the direction. So what do we do? Or who has found it already? I think that's that should be a hand. Yes, Keketse?
Yeah, I found 72.94.
The
direction.
As an angle.
As
You
an
found it as
angle.
an angle. 72.94
Yes.
degrees, right?
Just 72.94, yeah.
Yeah, degrees. And in which, how do I ask this question? 72.94 from the zero. Remember, we should have a reference because we should know the bearing. You did bearings. Yes, you want to add something, Leshonolo? You want to add something there? Because if it's 72.94, is this 72.94 from the, because you have 0 degrees there. This is your 90 degrees. This is ideally 180 degrees.
Actually, it's 72.14 from 10-meter line to final vector line.
To the vector sum.
Yeah, to the vector sum.
So
That's
which means
the
if it's with respect to the zero, we add 30 to it, we get 102. Because if it's from here to here, and you say it's 72.14,
0.94.
0.94, then
that's the direction.
then that means the actual direction is 72.94 plus 30 degrees because we have 30 degrees here. So if we add our, you're saying our total should be 102.94. That's your suggestion. How did you get the 72.94? I'll start with Leshonolo before Matteo, you can follow after that. Leshonolo, let's hear from you. Yeah, you probably are muted. Maybe you can unmute your mic. You can unmute your mic first.
Yeah, see, I was asking if the first angle that we are going to get there, isn't it gonna be negative?
It depends. What are you getting? I'm coming to you, Snenjongo. It depends. It depends on what. So if we come back to what Koketso suggested, depending on which angles you are using and how you are accounting for your directions, I agree with you. You get a negative direction. You should know what
Then
that
from
negative means.
means, yeah.
Yes. So whatever you do, you get a value. You should know its significance and act upon it appropriately. So that's why I have to ask you which method are you using and what do you get from that method and what do you do next, so that we have at least a working procedure or a method that we can adopt without problem. So in your case, what angle have you found?
Minus 17.05.
Minus 17.05. Okay. Minus 17.05. Okay. How did you get that angle?
Oh, I made a mistake. I made a mistake.
All right. So check where the mistake is and correct. Motio, what did you want to say? And Snenjongo, you'll be after.
So,
Yes.
after the summation of those vectors, which is A and B, we will find the y component and x component, and I guess our x component will be that one which is negative 7.41, right?
Okay.
And the y will be the 24.15.
Okay.
So
you're saying this is an x component and this is our y component because it's in the J. Okay, right?
So I said for theta, I said tan negative.
Arctan.
Yeah, arctan.
Mm-hmm.
Arctan 24.5 all over negative 7.41.
So you are saying arctan y over x, which is arctan 24.15
and I added
7.41. Okay. And what did you get?
And I added 180 because it gave me a negative value, which is negative 17 now. Could just add 180, so I'll give the final. I don't.
Oh, plus 180. Okay, plus 180 degrees. So you're
Which
saying
gave me
your theta is plus 180 degrees. Then it gave you
107.06.
Oh, wow. 107.06. Okay, so that's another value for theta. We'll hold on to your working. We'll come back to that one, Matthew. So that's quite cool. Snenjongo? Mr. Snenjongo, come in. Unmute your mic. Don't forget to unmute your mic. Otherwise, you'll be speaking alone in the room. Yes, we're listening. Oh, it's just one of those hands. Okay, I'm sure you come back in. Yes, Tandoletu?
I want to ask why the two angles are not equal if the second one is also correct.
Okay, right. There's only one correct one, actually. Right. The reason why they are not equal is because of the issue of directions. So I wanted, I think, Coquette, so I don't know if you are still using your method. You should let us know what you get if you continue with your method. So that's why I was saying the consistency becomes an issue here. So now let's start. I'll just leave these ones as is. It doesn't mean all answers are correct. I was just picking the different answers that we are getting to show that there should be some error somewhere. So far what we have done, we have worked up to this point. And the correct method is to apply this. So when you apply this, your theta is already, you have how do I put this? You have a resultant. You have a resultant that is given by minus 7.4i. So let me actually draw it separately so that we don't confuse with what we're seeing here. So we have a resultant of a plus d. So this is the a plus d vectors. And this resultant is simply minus 7.4i minus 7.4 in the I41 in the I direction with a plus 24.15 in the j, right? So these are the components of the resultant vector. These are the components of the resultant vector. So with these components, remember this already is the x, right? That's the x, this remains the y. So now, given that it means the actual resultant vector, which we can call it r, which is the same as this blue one here, the a plus d, that's the r. It is because of these two components. So that resultant vector here, yes, makes a certain angle with the x. We can call that angle phi, or you can want to deal with this angle. It's up to you. But the simplest is to deal with the horizontal angle, the one that is subtended with the horizontal line, the x. So let's deal with the phi. So when we're dealing with tan phi, let's start. I'll just leave these ones as is. It doesn't mean all answers are correct. I'm just picking. Oh, that's YouTube. Please just mute that here, YouTube. To show that there should be some error somewhere. So far what we have done, we've worked up to this point. Yes, beautiful hearing yourself. Who is this one? Likanye, can you mute the YouTube channel, please? Thank you. You have a resultant. You have a resultant that is given by Likanye. So let me actually draw it separately. Wonderful. Okay. Right. So what am I saying? If we have phi as this angle, we know that tan theta is equal to adjacent. This is what you have always sung since you were born. Adjacent over opposite of adjacent. Opposite of adjacent, sorry. Opposite over adjacent, right? In this case, the opposite is the y. The adjacent is the x, right? So when we want phi, then we take arctan of the opposite over the adjacent. That's why we have the y being 24.15. So that means that's arctan of 24.15 all over minus 7.41 with its sign, right? If you work that one out, you find your phi is equal to negative 72.95 degrees. So it means this angle phi, any other nice color here, purple. So it means this phi is 72.95 in magnitude. Why is it why is it negative? Because it is in this particular quadrant here. It is in this second quadrant. So because of that, if you just subtract this from the 180, what you get? You actually get this angle. This is the 107. That who actually gave us the 107? I didn't check that name. The one who gave us 107. The last answer here. I hope so. This one, 107 point. So it is actually a result of subtracting this 72.95 from 180 because the 180 is there. The 0 is here. Then we find that this angle is actually 07.06 or 107.1 degrees. That's how we get that. Or otherwise, if you do your turn based on this, you just get that angle and add it to 90 and still come back to that solution. So it makes 107.06 degrees the correct answer. But you have to use the turn because remember you already have components. So with the components in place, you just do a component, a arctan over the y component over the x component, and then you get the angle. And you should know where that angle is. So in this case, this angle lies in the second quadrant. So we subtract from 180. It's minus 72.95 from 180. Okay, thank you for that, Mbali. And Motheo, do you still have a question? Your hand is up.
Unless I forgot to.
Okay, no worries, no problem. But do you understand why we get a negative and then we have to operate on that negative? Because it's because the direction of the x is already in the negative x component. So you get a negative 72, meaning it's moving from the horizontal opposite the conventional direction that we know when we are increasing our angles from 0 to 90, 90 to 180. But this one from the horizontal is going in the negative 72.95 from the 180. So you go back to 107. That's why you get a negative because of this negative I component. It's because of that quadrant there. Okay, any question? Any burning question? I think you guys were awesome. You at least were talking. You managed to contribute. You gave us correct answers. We commend you for that. But I hope you also learned something in the process. Do we have any other question? Yes, Lishonolo?
There was the other question that included a triangle.
It's not included where? Come again, I missed the last part.
There was the other question that has in a triangle.
Okay, which question was that?
You had in a triangle. Say the ABC.
Let's see. Are you not considering the questions that were sent by Lucian? Let's see. Tell me if it's one of these. Question 5. It had a triangle. I don't see anything with a triangle there besides the other diagram. Is it not the one that has, we did the one with the distance? Measuring displacement. It's not this one.
No.
Where did you see the question?
Inside this text.
So you should take note. Take note. There's actually two sets of questions. There are these practice TAT quiz questions. Then there's the practice. There's the TAT quiz for marks. There's the another one which is for marks. So just make sure you know which one it is. Because for this one, we're just taking the practice quiz questions, not the ones for marks, because those ones are for your assessment. So I'm sure if you saw one in the TAT 1 practice quiz for marks, then it could be the question you are mentioning. Maybe just check while you are still here and let us know. Yes, Kaketso?
Yeah, actually, sir, I redo the question. So, like when I was analyzing it, I saw that my mistake was like you mentioned something about there will be problem when in finding direction, right? So I analyzed it and I realized that my mistake is like where I should draw an angle. I didn't find a way to draw an angle. So in fact, I should have drew a Cartesian plane. I constructed my own Cartesian plane,
Right.
which is gonna be parallel to the original one. That's how I get the direction.
The correct
So
direction.
Yes, I got the correct direction.
Okay. Yeah, so it actually needs you to really be quite meticulous in the way in which you would have restructured your angles and your direction. That's why I was saying consistency becomes key. Because the moment you just miss a direction or an orientation in a way, your direction won't come out correctly. So that's where it becomes important. Magnitude is not a problem. Magnitude is just quantity. But vectors have directions, and so those directions need to be considered in their specific orientations. So thank you for that. Thank you for highlighting that. So it's also important to know the strengths and weaknesses of each and every method, and so you will be able to choose appropriately or which is the best approach you can use and can apply in a variety of scenarios without giving you problems, because the least thing that you want is having problems or having to think a lot. So I think that's quite cool. Thank you, Kokeso, for highlighting that. Any other question? Yes.
So by saying that you mean that when after calculating a vector and you get maybe a quantity with a positive direction, but you know that this component should be negative. If you just give that value a negative, are you going to be penalized? Nah?
Yeah. Yeah, you'll be penalized, because I mean it's good to reason that way. I like the reasoning. At least if you see, because it means you are actually quite focused and you are aware of what's happening. But then it becomes a challenge. You are most likely gonna lose some part marks in the method, because the negative cannot just appear from the air or from nowhere. So that's why it's important to always follow the correct method, because it means something is wrong in your method. Unless if you excuse me guys, unless if you explain and you are calculating, let's say, magnitudes, and in your calculations you are following that these are magnitudes, and then you state that these magnitudes are based on directions that consider the negative direction to be opposite to what you have in terms of a certain vector, then you give it the negative direction with justification. Then at least that reasoning or that explanation, you get my point. You have to explain that because it's in the opposite direction to vector A, its direction is therefore negative. So you have its magnitude calculated properly, but then you justify why you are introducing a negative at the end. Do you get that, Matteo?
Yes, sir. Because you know why? Because when I'm using this, the angle from the 180 from the second quadrant, x axis.
Right.
Let's say here it was 180, right? When I'm using that 50, that 50, yeah, when I use that 50, the direction of the component of the x component will be positive. That's why I substitute a negative. That's all.
I see. Yeah, so that's actually quite important. Once you use that 50, your direction in the x component shouldn't be positive because it's already negative. So when you introduce it with this negative and you show that the angle there is 50 for a component that's in the negative, the system comes to autocorrect. So you have to just be careful with the signs there. When do you put the signs? When do you use it? And you should not use them in such a way that they end up nullifying each other. To say, if you use a positive 7.41 and a 50, already you're actually coming back to the first quadrant, and that already nullifies everything and makes it wrong. But if it's the 50 there and the minus 7.41, then already you would know that whatever working you do there and you get your angle, at the end of the day, remember the 50 actually was for the initial component that's subtracted. But then what you need to find now is this angle, the phi, which is the new component for the sum. So if this was your 50, then now you need to find this phi, which is to the new vector. And when you do that, because you have a minus 7.41 there, you would find that angle But you know that when you're calculating your angle, when you're giving or mentioning an angle in terms of directions, you start with your 0, the reference is this one along the positive x. So then you subtract whatever you get. You are most likely going to get the 72.94. This 72.94, I don't know where it got this. It's actually here and not between the A and the new vector. It's actually 72.94 between the x component and the new vector. So this angle was actually the angle for this part. But anyway, once you do that and you are consistent with your directions and everything comes into place. I hope you answered any other burning question. Thank you, Mothio. If there are no further questions, this is the last question of the day. Would advise you also, as you do your practice and you read through your textbooks, if you find any questions that are challenging or that give you trouble or that you feel you don't understand, you are allowed to bring them over. You can bring them over and we'll gladly assist you and explain what will be happening there and how you have to go about it. But for your advice, it's important that you try and work it out first, because what I would usually do is ask, how did you work it out first and where did you hit the brick wall? Then we can pick it from there, because what we need to do is identify where you are facing challenges rather than just giving you answers. That won't help you much. So it's important that we first analyze and see, okay, this is where you are making a misconception. Then we can address that, and that actually helps you in the long run. So thank you guys. Thank you for your participation and for your time. We hope to see you again in the coming week. Every Wednesday, Thursday, and Friday we'll be here live on Yebo Physics to help you. So from me and everyone in the studio, it's bye-bye for now. Enjoy your weekend. Don't forget to study. Bye-bye.